This is Getting Started with GeoGebra. I'm Professor Arlo Kane, Mathematics and Statistics, California State Polytechnic University, Pomona. We're going to be working with the software GeoGebra, which presents you with options to do a number of things. Across the top of the GeoGebra window is the toolbar. There's various tools here that you can select with the mouse. And if you click and hold down on one, it brings up more tools under those buttons, so they're actually categories of tools. For example, we can go over here to the point tool, and when we click somewhere in the window, it'll create point, and this side is called the graphics view, and on the left is called the algebra view. It shows the coordinates of that point together with its name. To rename an object, you can right-click on it on a PC or on a Mac. It would be the pound click. And one of the options is rename. It brings up a dialog box, and you can give it a new name like P. Okay. And you can go back to the point tool and click another object. Maybe rename that one Q. And we can create the line between 2 points, for example, using the line tool. So select the point P, select the point Q, and there's the line between them. And notice that if you move the point P around, the line adjusts, and if you move the point Q around, the line adjusts. So it's describing the unique line determined by those distinct points. For any graphics object, whether it's the points or the line itself, you can change their features or appearance using the graphics menu, which is this little word graphics here with a triangle next to it. If you click on that, it brings up an option to change the color. Notice that the line is changed to a color green. You can change the style of the line, making it dashed. You can also, if you select the line again, change its thickness by selecting the style, and coming down here you can increase the thickness by adjusting the slider. One of the things that will be important to know if you're new to GeoGebra is you can always undo what you just did by clicking the undo button or by using edit undo from the file menu. So undo, notice that it goes back to my different styles of lines, and you can do this as many times as you need to change and get back to where you wanted to be. We're going to go ahead and create a new window now. I'm not going to save any changes, so it starts me over again. It's moved the graphics coordinates to a different position. You can move them back by using the Move Graphics View tool. Just grab the plane and slide it up so you can see the same image again. Now, what I'd like to do is talk about the assignment E as a model of incidence geometry, where we verified the axioms of incidence. In particular, we verified axiom of incidence 2, which says that if you had a line in this interpretation, which is the solution set to a certain kind of equation, then there has to be at least 2 solutions. And we found formulas for points that lived on such a line in terms of the parameters defining the line. We can visualize that and check our formulas in GeoGebra as follows. First, we're going to create parameters A1, A2, and C using a slider tool. By moving the sliders back and forth, we'll be able to adjust the values of the parameters. Remember that a line given by those parameters, A1, A2, and C, is the solution set to an equation that we can just type in down here at the bottom in the input bar. A1 times X plus A2 times Y equals C. When I hit enter, it draws a line, and if I click on the Move tool, I can adjust the sliders and notice that the line changes correspondingly. Now let's go back to our formulas. we found that if A2 is non-zero, this corresponds, remember, to lines that are not vertical, then we were able to solve our equations and find formulas for specific points on the line given by these. Let's go ahead and type those in and check if it works. So going back to GeoGebra, we'll go down here to the bottom input bar and we'll enter the point 0, c over A2. When I hit enter, I observe that that point is on the line. And if I adjust my sliders to adjust the line, that point stays on the line through the adjustment. Secondly, our second point we found was 1, c over A2 minus A1 over A2. That point also appears on the line, and as I adjust the sliders, those two points are always on the line, and they give two distinct points on the line. Now what I want to observe here is that our formulas had A2 in the denominator, so they are undefined when A2 becomes 0. Let's observe that in action here. If I move the slider A2 so that its value goes down to 0, notice that over in the algebra view, the points A and B that we created are listed as undefined. So we had different case logic. In that case, we had to use some other formulas. Let's go back and see them again. We were going to use c over A1, 0, and c over A2, 1. So let's go back to GeoGebra and plug those in. If we enter the formula as c over A1, 0, I get a point on the line, and c over A1, 1, I get a point on the line. And if I leave the A2 at 0, which is what I'm supposed to do because that's the case I'm in, but I move the A1 slider, I observe that those points are on the line, and if I move the C slider, those points stay on the line. So in all of those cases, well, we've managed to show there are at least 2 points on a given line. All right, let's go ahead and make a new window and talk about verifying axiom of incidence 1. So again, I'll move my coordinates up a little bit using the Move tool, or the Move Graphics View tool. I'll go back to the Move tool. Our formulas, remember, we thought about, well, if we had points which are given by ordered pairs of numbers, then we solved for formulas for the coefficients, which would then determine the equation of a line of that type that should pass through those points. We can check this as well. So let's go back to GeoGebra. Let's create 2 points using the point tool. So we'll rename this one P, and another point, we'll rename this one Q. Down at the input bar, let's now compute the elements of our formulas, which involved finding the coordinates of these points P and Q. So we had P1 is equal to the x-coordinate of point P. P2 was equal to the y-coordinate of the point P. Q1 is equal to the q-coordinate of the point, of the x-coordinate, the first coordinate of the point Q. Notice here that this input bracket has been turned red. That's showing me that I have a mismatch. It doesn't have a matching bracket over here, so I better delete that. And when I hit enter, it'll calculate Q1. And then finally Q2 was the y-coordinate of the point Q. Enter. Now I need to define the parameters A1, A2, and C using our formulas. So A1 is Q2 minus P2, A2 is minus Q1 plus P1, and C was given by a kind of determinant expression using the P's and Q's. So let's plug that in. A1 is going to equal Q2 minus P2. A2 is going to equal minus Q1 plus P1. And C is the determinant expression, P1 times Q2 minus P2 times Q1. And now let's plot the line A1 times X plus A2 times Y equals C. Notice that it passes through the points P and Q, and if we move P and Q, the line adjusts. In fact, these formulas are exactly how GeoGebra calculates what to put as the line between 2 points and embeds that code in the line tool I used from before. So whenever you're using GeoGebra, you're actually using the algebra that we worked through for E as a model of incidence geometry.